Hello to anyone who's watching this video. Today I will be talking about cryptographic failures as a software weakness. Before we move on, let's have a look at what the contents of the presentation will be like. First, we'll have an overview of the topic, then we'll get into the description and the identification of the problem. Then we'll look at the preventions that are possible for it. Then some example scenarios. Then I will talk about a real life example of this issue, and then conclude. Now let's get into the topic of cryptographic failures in software security. Cryptographic failures as a category has been ranked number 2 in the OWASP's top 10 for 2021. OWASP is the Open Web Application Security Project, which is an open source database which contains all kinds of methodologies, prevention cures, and documentations related to any sort of software security issues that have been documented till date. Now let's understand what cryptographic failures is. Essentially, it was previously known as sensitive data exposure, and it is pretty much what the term says. It's the exposure of sensitive data and a failure on the cryptography part of it. Let's now look at some of these statistics. According to OWASP, we have a total of 29 CWEs mapped. They have an average incidence rate of 4.49%. The average weighted impact is 6.81, and then the average coverage is of 34.85%. So now let's dive deep into the problem and see what it is all about. Firstly, we need to understand why cryptographic failures is a problem. Well, for starters, our data is important to us. Most companies rely on their data, and that is all their product is about. Our data needs to be protected, whether it is in transit or whether it is at rest. We see attackers trying to find clever ways to obtain data, and if the data is not handled in a secure way, this is a really big issue. What kind of data you're talking about? Well, we're talking about passwords or credit card numbers, health records, personal information, order details, and pretty much any sort of data that you would find or a company finds sensitive or valuable. Now, what should we be worried about when we are talking about cryptographic failures? Well, is the data that we are transmitting, is it being transmitted in clear text? Because that is an issue. This kind of a problem concerns protocols such as the HTTP or the SMTP or even TLS upgrades like the Start TLS. External internet traffic can be very hazardous, and it is very important to verify all internal traffic. Are any old or weak cryptographic algorithms or protocols used either by the default or the older code? Is the encryption not enforced? For example, are there any security directives enforced in the HTTP headers? Are we using any deprecated hash functions such as the MD5 or the SHA-1? Are we using any deprecated cryptographic padding methods such as the PKCS? Are cryptographic error messages or side channel information exploitable? For example, in the form of padding or ACL attacks? If our error messages are too descriptive, the attackers can simply run errors and understand the back end of the system and simply find new ways to exploit and obtain the data. Is the receiver certificate and the trust chain properly validated? This is extremely important as most of the network traffic has to be validated and ensured that it is completely secure. Now these are what are the different ways, and there are many more, but essentially these are some of the ways where we can try and understand that, hey, if we are not able to follow some of these precautions or our system does not implement some of these issues, then we are definitely at risk of a cryptographic failure. Now let's talk about the different preventive measures that we can take. We need to identify which data is sensitive, and according to the different privacy laws and regulatory requirements or even business needs. We should not store sensitive data unnecessarily. Discard it as soon as possible or use PCI DSS compliant tokenization or even truncation. Data that cannot be retained simply cannot be stolen. Make sure to encrypt all of your sensitive data at rest and in transit with secure protocols such as the TLS with forward secrecy ciphers, cipher prioritization by the surfer, and secure parameters. Disable caching for the response that contains sensitive data. This is mostly related to the browser. Do not use legacy protocols such as the FTP and the SMTP for transporting sensitive data. Always use authenticated encryption instead of just simply encryption. Keys should be generated cryptographically randomly and stored in memory as byte arrays. If a password is used, then it must be converted to a key via an appropriate password-based key derivation function. We can also verify independently the effectiveness of our configuration and settings. Now let's look at some of the notable CWEs listed on OWASP's website related to cryptographic failures. CWE 259, use of hard-coded password. 327, broken or risky crypto algorithm. Insufficient entropy. 331. 325, missing required cryptographic step. 336, same seed in pseudo-random number generator. 523, unprotected transport of credentials. Feel free to go to their website and look these CWEs by their numbers for more information. Now let's look at some of the example attack scenarios. First scenario, an application encrypts credit card numbers in a database using automatic database encryption. However, this data is automatically decrypted when retrieved, allowing a SQL injection flaw to retrieve credit card numbers in clear text. In a situation like this, where an application is using the automatic database encryption methods to encrypt the data, is simply not enough. We need to find better methods to encrypt our data with more secure protocols. SQL injection attacks are very common with databases, and if a successful SQL injection goes through, the data is going to be available in clear text. Scenario 2. A site doesn't use or enforce TLS for all pages or supports weak encryption. An attacker monitors network traffic and then downgrades connections from HTTPS to HTTP, intercepts requests, and steals the user session cookie. The attacker can then replay this cookie and hijack the user's session, accessing or modifying the user's private data. Instead of the above, they could alter or transport data. Example could be of the recipient of a money transfer. This is a very common scenario where cryptography is extremely important and needs to be enforced properly. If if the website is not using the appropriate protocols, then an attacker, as I just said, could very easily be able to hijack a user's session and then have access to all of the user's data. They can simply then even transfer money to their own third-party bank accounts before the user even realizes that someone else has been using their information, and the website's protection is no longer being enforced. Now let's look at a real life example of a cryptographic failure. This particular failure is categorized by the number CVE 20200664. Essentially, this can be categorized as a hard-coded cryptographic key failure. Now let's see what this is all about. NetMaker is an application that enables easy deployment of a mesh VPN based on WireGuard. To authenticate and manage users throughout the application, it uses JWT tokens. The secret key used to sign these tokens is hard-coded, which means that they can be faked. So an attacker can create a valid authentication token for any user and use it with admin privileges, since the privilege verification is implemented on top of that. This particular CVE has a CVSS score of 10.0, which is as bad as it can get. It has an integrity impact of complete, which means the total information, which means a total compromise of the system's integrity. There is complete loss of system protection, resulting in the entire system being compromised. The availability impact is complete as well. There is a total shutdown of the affected resource. The attacker can render the resource completely unavailable. The access complexity is very low. Specialized access conditions, extenuating circumstances such of that does not exist. There is very little knowledge or skill required to do such an exploit. Clearly, this particular CVE clearly has a very high score, and it makes sense. Now let's talk about the impact of this CVE. The attackers would gain admin privileges, they would have access to the user's information, and they would have complete access to the database that stores all of this information. The consequences are more severe. Attackers, now that they have admin level privileges, can perform any action that they want. They can also pretend to be different users and perform these actions, creating a discrepancy between an actual user doing something illegal or an actual attacker pretending to be a user. They could use the user's personal information for their own benefit by selling that information to any third-party vendor. They can also now delete and remove tables from the database, causing complete loss of information if it is not backed up. Now let's look at the fix that was implemented. Essentially, the developers decided that the fix required was to generate a JWT token in a new JWT token in the installation process. You can have a look at the code here and see that they are creating a new token which is of 512-bit random password. So to conclude, cryptographic failures have now been more prominent than ever. We are finding more and more cryptographic failures every day, and according to OWASP, they are the numbers. This category stands at number 2 in 2021. Cryptographic failures are definitely preventable if the appropriate steps are taken and the appropriate protocols are followed with the valuable and sensitive data. Overall, cryptographic failures tend to have a higher CVSS score than other types, as breaking the cryptography tends to give the attackers complete access, and without the knowledge of the administrators, they can perform a lot of problems. And in short, these failures need to be taken more seriously, and since they are on the rise, new protocols need to be created that specifically handle such problems.